Dear students, today we are going to discuss conductometric titrations. These are the titrations in which conductance is measured with the increasing volume of alkali added. Now, a graph is plotted in conductometric titrations. So consider first titration as strong acid, strong base titration, that is titration between HCl and NaOH. Now, it is a graph which is plotted between addition of or increasing volume of NaOH. You go on adding NaOH from burette 1 ml or 0.5 ml at a time, and then go on adding NaOH and go on measuring the conductance of the solution. HCl is taken in the beaker. Now, this is the graph which is obtained between a strong acid and strong base titration. Initially, see, the graph is between volume of NaOH added and conductance. So initially the conductance goes on decreasing sharply, and then after the endpoint is reached, the conductance goes on increasing, and this point is the endpoint. Now, why it happens so? Firstly, the conductance decreases sharply because the faster moving H plus ions which are present in HCl, they are replaced by Na plus ions, and that's why Na plus ions are bit slower moving than H plus ions, and therefore conductance goes on decreasing rapidly. And once the HCl is consumed completely, and if you go on adding NaOH, the faster moving OH minus ion concentration goes on increasing, and therefore you get increase in the conductance, and you get such type of a graph between strong acid, strong base titration. The second titration is a weak acid, strong base titration. Weak acid is acetic acid and strong base is NaOH. Now, graph is very interesting. See the graph, and we will also see how this graph is obtained. Firstly, when you add NaOH from the burette and acetic acid is taken in the beaker and conductance is measured, initially the conductance decreases, then conductance slowly goes on increasing up to the end point, and when complete acetic acid is neutralized, the conductance sharply increases, and this is the end point which is obtained. Now, initially H plus ions from acetic acid, they are replaced by a salt CH3COONA, and therefore initial decrease in conductance is observed. Then slowly conductance goes on increasing because the sodium acetate which is formed, that undergoes ionization, and acetate ions which are formed, and sodium acetate is a salt which is ionized, and therefore you get a increase in conductance. And after complete neutralization there is a sharp increase in conductance due to the increase in concentration of faster moving OH minus ions, and this is the end point. This is weak acid, strong base titration. The third one is strong acid versus weak base titration, that is HCl with NH4OH. NH4OH is a weak base. The graph is like this. The conductance goes on decreasing. Again the graph is same. On x-axis volume of base, that is NH4OH added, and on x-axis volume of NH4OH is added, and on y-axis conductance is measured. Conductance goes on decreasing first, and then it almost remains constant or horizontal to x-axis. Why it is so? First go on decreasing because H plus ions are replaced by NH4 plus ions, therefore there is a decrease in conductance, and after equivalence point is reached, what will happen? There is no change in conductance, almost remains constant, because after neutralization the NH4OH when added from the burette, does not ionize appreciably in presence of NH4Cl, because NH4Cl is already formed in the beaker due to the neutralization of HCl. What happens after neutralization? That the conductance almost remains constant, because after neutralization, if you go on adding NH4OH from the burette, this NH4OH does not ionize appreciably in presence of NH4Cl, which is already formed in the beaker, and that's why the conductance almost remains constant. So this is the nature of the graph. Initially conductance goes on decreasing and then almost remains constant.